right, Trig, Chapter 5, Lesson 5, Double Angle Identities today. So the double angle identities, these are given on your formula sheet. You have, I've given them to you on a copy of pink paper in my classroom. You can also find these identities on the College Canvas website. So if you're at home and you need the formula sheets, just open it up on the Canvas. You can print one at home to have there. In class, I provide you a copy of them. The sine of 2a is given as 2 sine of a cosine of a. I like to go ahead and talk about the proofs of each of these. So if I was to rewrite that, the sine of 2a as the sine of a plus a right here would be 2a. Now, I'm going to use the sum and difference rules at the top of your formula sheet. You notice when I do that, if this is the cosine a times sine a, that would be the same thing as sine a times cosine a. And that's where the rule comes from of 2 sine a cosine a for it. All right, cosine double angle, cosine of 2a. That'd be the same thing as cosine of a plus a. Again, use the sum and difference rule at the top of your formula sheet. Sorry about that, guys. And this is what you would get. Now, that gives me cosine squared minus sine squared. So there's the first identity. Now, where do these two identities come from? If you will remember your Pythagorean identities for your trig class, that would help you know where the other two came from. So the Pythagorean identity, for example, if I looked at what does cosine squared equal, let me go ahead and pull this up real quick. So we had a Pythagorean identity of cosine squared right here, it would equal 1 minus sine squared. So if I was to substitute 1 minus sine squared for this cosine squared, 1 minus sine squared, that gives me the 1 minus 2 sine squared. Let's go ahead and substitute for sine squared instead. So let's come back to that identity. And right here, if I solve for sine squared, that would be 1 minus cosine squared. So that would be minus 1 and then minus a minus cosine squared. And that's where we got, so 1 minus 1, and then that became plus cosine squared, plus that one, and that gave me a 2 cosine squared. And then, like I said a minute ago, that's where we got the other one. All right, tangent of 2a be the same as tangent of a plus a. And again, use your sum and difference rules. And then notice the denominator, you have tangent of a times tangent of a, and therefore that's simplified to tangent squared of a. So we were able to show you where all those rules came from. All right, please make sure you have your formula sheet sitting out in front of you. I also tend to go ahead and put them over here on the right, so that way we all have them at the same time. The first here we're going to be looking for is always want to look to see if you have anything happening here. If you have one of these scenarios happening, you want to go backwards on it. It makes it a little easier. I'm noticing for this first problem, it looks like to me, it's the cosine 2a. It looks like the second rule to me. There's the 2. There's the cosine squared, angle A minus 1. So for angle A, I'm going to plug in right here 157.5 degrees. 2 times that would be 315 degrees. That's going to put me in quadrant 4 with a reference angle of 45 degrees. Now in quadrant 4, all students take calculus, the cosine would be positive. Therefore, that's why this is equivalent to the positive cosine of 45 degrees. Then if you drew your 30-60 and 45-90, if you need to, pause the notes, draw your pictures for 30-60 and the 45-90. The cosine at 45 would be your radical 2 over 2. Alrighty, this one tends to look like the very first rule to me. There's 2, there's sine, there's a, cosine, there's a. So the a is pi 6. We're going to go back, and that's going to be the sine of 2 times pi 6. 2 times pi 6 would give me pi thirds. Pi thirds is equivalent to, hopefully you're thinking 60 degrees. See, 180 divided by 3 would be 60 degrees. The sine at 60 degrees, if you drew your 30, 60, 90, you would know that's radical 3 over 2. Simplify the expression. So again, hopefully you're looking through these rules. Does this first one look like that? Nope. Is it cosine squared minus sine squared? Nope. Is it this one? Yes. The a is the 5x. So to go backwards, it's cosine of 2 times my a. That means cosine of 2 times 5x. So the cosine of 10x. Now problem B kind of looks like the very first one, sine times cosine, except it's missing the 2. So what if I did 1/2 times 2 in front of this? See, I really didn't change the problem. I really just multiplied by a fancy 1. A half times 2 is just 1. Now, I'm going to have 1/2 times all of this part I'm going to use the rule for, which says the sine of 2 times angle A. So 2 times the sine of 165. 165 doubled would give me 330 degrees. Now, 330 is going to put you in quadrant 4 with a reference angle of 30 degrees. Hopefully you were thinking that. So again, 330 degrees would put me in quadrant 4 with a reference of 30. How far off of 360 is that? 30 degrees off. Now the sign in quadrant 4, all students take calculus, it would be negative. So this is equivalent to negative sine of 30 degrees. Now if you had drawn your 30-60 right triangle just a minute ago, the sine at 30 you know is 1/2. That's negative 1/2 times 1/2. My answer would be negative 1/4. I'm given the sine of theta is 8/17. I'm given the cosine of theta is a negative value. We're supposed to find the sine of 2 theta, cosine 2 theta, and tangent 2 theta. You guys, first off, this picture right here is going to be for theta only. Sine of theta is 8/17. The cosine is negative. So where is the sine positive and where is the cosine negative is the first thing you should be concerned with. So again, where's the sine positive and the cosine negative? So all students take calculus. So hopefully you were thinking quadrant 2, because that is correct. This is a picture of where the theta falls. Now, in quadrant 2, my x is negative, y is positive, and r is always positive. The sine is y over r. This is a picture for theta. So y over r, 8/17. Pythagorean theorem, 17 squared, take away the 8 squared. The square root of that is going to give me 15. Now, using my rules, the sine of 2 theta says it's equal to 2 sine theta cosine theta. Well, 2 times the sine of theta they already gave me, but we also know the sine of theta would be y over r, 8/17. The cosine of theta, here's the picture for theta. The cosine would be the x over r, negative 15/17. Then we just go ahead and multiply those tops, and the bottom 17 squared, and that one is done. The cosine at 2 theta, you actually had 3 of them to choose from. I'm going to explain to you why I chose the third one. Normally, I would choose the first one. If I knew I was confident, if I was really confident that this was all correct, I actually would choose the first one because then my fractions would already have a common denominator. Choosing the one I did just now, this is a 1, and this is going to have a denominator, and I'm going to have to get a common denominator between these. But if I had messed up on my picture, then the value for the cosine would be wrong, and if I'd use formula 1 or 2, then my answer would be wrong. So at least using the third formula in this case, since they gave me the sine, I know that that answer is right for sure of 8/17. We square that, that's 64 over 289, times by 2, so 128 over 289 for this part of the fraction. And then remember, you want to get a common denominator, so that's 289 over 289. So 289 take away 128 is 161 over that common denominator of 289. Now at this point, you could use your tangent rule for the 2 theta. I personally don't. I go ahead for tangent of 2 theta. Since I already have both of these answers, I know it's going to be sine 2 theta divided by cosine 2 theta. I do know that these two denominators are going to reduce, so therefore I have negative 240 over 161 for my answer. Find the values of the 6 trig functions given the cosine of 2 theta is negative 12/13 and the original angle is between 180 and 270 degrees. That means my original angle would be in quadrant 3. So there's the picture for the original angle. The x's would be negative, y's would be negative, r's will be positive. I went ahead and went to the cosine double angle rules. I do not use the first one. It doesn't matter if I use the second or the third, but I cannot use the first one. The reason I cannot use this first one is because that would give me 2 unknowns of cosine squared and sine squared. If I use either one of these, I only have 1 unknown, which is what I need. Okay, so again, I just went ahead and chose the 1 minus 2 sine squared, no particular reason. So therefore, the cosine of 2 theta, we're going to use this for this left side right here. That equaled the negative 12/13. So first thing I need to do is subtract 1. That means I'm subtracting 13 over 13. So that's why it's negative 25 over 13. Need to get rid of the negative 2. So I multiply both sides by negative 1/2. In doing so, sine squared is 25 over 26. To get rid of the square root property, to get rid of squared, you do plus or minus your square root. So square root of 25 is 5, square root of 26. Now, y'all, when I come back here and look at my picture for a second, remember my sine of theta here has to be a negative value because y has to be negative. See, therefore, my sine of theta has to be just the negative 5. So y is negative 5, where the r is the radical 26. Then I can use my Pythagorean theorem, and I can get my x value. Now, I'm supposed to find all 6 trig functions here. So therefore, the cosine of theta would be x over r, sine of theta is y over r, the tangent is y over x, and then all the reciprocal identities after that. So again, the sine was the y over r, the cosine is x over r, the tangent is y over x, the reciprocal of cosecant is the sine, the reciprocal of the cosine is the secant, and the reciprocal of the tangent is the cotangent. They gave you a couple problems on the homework of doing verifying. If you take a look at your multiple choice on these, you'll know to start with the left or the right side. Since I did not do the notes as a multiple choice, I'm telling us what side to start with. So they're telling us to start with the left side. So we're going to take this binomial and we're going to square it. After I've done that, I'm going to move these two together. And if I do so, if I factor that 4 out, I want you to notice here, that is a Pythagorean identity. After your Pythagorean identities, hopefully most of you realize that that is a 1. So 4 times 1, that would be 4 plus 8 sine theta cosine theta. Now this also looks like another identity to me as well. See, if I factor that as 4 times 2 sine theta cosine theta, that's one of your new identities today off your pink sheet. That is your double angle identity for sine of 2 theta. Now, I put little arrows by most of these problems because this was one of these in the homework that actually was not multiple choice. It wanted just certain steps of verifying the identity in the computer system. So first it wanted you to expand this out or FOIL it out. So that was your first step. The second answer was this. They wanted you to simplify, and so that was pulling this one over, factoring that 4 out, and then using a Pythagorean identity to get to here. And then from this line to this line, we use the double angle identity for the sine. So again, in your homework, you will find what problem this is similar to, and you will probably come back to this slide. You should have a copy of these notes, so you can just refer back to it in your binder. All right. Again, we're going to FOIL out our left side. So I do that. Again, I'm going to move these two together. And remember, a sine squared of an angle plus a cosine squared of an angle is equal to 1. So this is equal to 1 plus all of that. Now this hopefully is looking like a double angle identity to you. So the double angle for the sine. So sine of 2 times the 2x, and this would be my final answer. So again, the step 1 was to FOIL out or box out. Okay, that's step 1 for your answer. Step 2 for your answer, we did the Pythagorean identity. The sine squared plus the cosine squared gave me the 1. Then from this step to this step, we use the double angle identity. And again, the arrows are pointing out to the main answers on this. Again, they told us to start with the left side again. So we know the tangent is the same as the sine of x over cosine x. The cotangent is cosine over sine. If I get a common denominator, that would mean I need to multiply this fraction by sine of 6x on top and bottom. The second fraction by cosine of 6x on top and bottom. Now that I've done that, in the numerator, I've got sine squared of an angle plus cosine squared of that same angle. That right there is my Pythagorean identity of 1 on top. Now, 1 over sine is equivalent to the, actually, I'm sorry, let's rephrase that. This down here almost looks like the double angle identity to me. So if I multiply the bottom by 2 and the top by 2, I really multiplied this fraction by a fancy 1, so I didn't change it any. See, now the denominator definitely looks like a double angle identity from the sine rule, sine of double angle. So that would be sine of 6x times 2 on the denominator, so sine of 12x. And then if you bring that up, that would be the cosecant of 12x times the product of 2. Sine of 2g, cosine of 2g equals, and this time they told me to start with the right side. So I'm going to start with this side. So when I do start with this side over here, that was a double angle identity. So I rewrote it as 2 sine g cosine g. Now, out of both of these, I can factor out a 2, and I can factor out the sine of g. So I factored out 2, sine g, cosine g. Left with a cosine squared, also a 2 out of that. Took out the 2, took out the sine, took out the cosine, so I was left with a 1. Now, this right here, y'all should be seeing that as a double angle identity. That happens to be the cosine of 2g. This is also a double angle identity. That one's the sine of 2g. So therefore, I have a double identity here for the cosine. I have a double identity here for the sine. So again, the arrows are pointing out the different answers along the steps in your homework system. All right, verifying that this is an identity. So this, I notice, is a difference of squares. Cosine squared, sine squared, 1 minus, 1 plus. 1 plus, 1 minus. Oop, look at this one. See, cosine squared of an angle plus sine squared of that same angle, this is always going to equal 1. Cosine squared minus sine squared, though, if you take a look at your identity sheets from today, hopefully you notice that's going to be cosine of 2 times that angle. So this right here became cosine of 2 beta. And therefore that identity has been proven. So these were your double angle identities for today. I hope these notes have helped you. Please try to do at least the multiples of 3 prior to coming back to class. You guys have a great day.